Okay, now we're going to move on to day two. Day two is where we kind of focused on the alternative definition of the derivative. So again, I'm going to go and share screen. Um, Here is what we have there. What we have here is now we are dealing with, I'm trying to close one thing out. Okay. We are dealing with, instead of this, where this is a general form of the derivative, I'm going to actually look at finding the derivative or the slope at the given point. I'm going to go right to the answer. So instead of using the x plus h thing, which is kind of getting close to it from either side and getting a general form, I am going to use it where I'm going to go to it at a specific point. So in this case, I want to go to it at x equals 2. Okay, so I have f of x equals 3x squared. That's my function. I want to use the following expression to try and figure out the slope at a given point. So it's f of x minus f of c over x minus c. Okay, so what I'm going to do now is I'm going to say, oh, well, in this case, c is going to be 2. C is that idea that I'm looking at. So what I need to know is I need to know f of x is 3x squared. What is f of 2? F of 2 is going to be 3 times 2 squared. 2 squared is 4. 3 times 4 is 12. So f of 2 is 12. So to figure out this limit at 2, so I'm figuring it out at 2. This one is a general form. This one's exactly at 2. I'm going to say it's equal to f of x, which we know is 3. It's equal to the limit as x approaches 2 of f of x, and f of x in this case is 3x squared, minus f of c. Well, f of c is at f of 2, that's 12. And that whole thing is going to be over x minus 2. So now, the first order of business is always plug in the number and see what happens. So when you plug in that 2, 2 squared is 4, 3 times 4 is 12, 12 minus 12 is 0, 0 over 0. This tells me I got to do some factoring. So what I'm going to do is I'm going to, in this case, GCF up top is 3. It becomes x squared minus 4 over x minus 2. Doesn't help me because it's now still 0 over 0, but I notice I can factor that numerator. It's the difference of squares. It becomes 3 times x minus 2 times x plus 2 all over x minus 2. Those x minus 2's cancel out. Now what that tells me is if I plug in that 2, 2 plus 2 is 4, 3 times 4 is 12. What that's going to tell me is the limit that f prime of 2 equals 12. What that is the slope. So the equation of that line would be using point slope form y minus 12 equals 12 times x minus 2. And that would be my equation of the tangent at x equals 2. Okay. I'll leave this. I gave this one in class. I'll leave you to try this one again on your own and then compare your notes. I'm going to just show some other ways that this is done. So here's the thing I want to do is I want to try and estimate w prime of 5. So if I want to estimate w prime of 5, that's basically what is the slope at 5. If I look at this table, something I'm hoping you should notice. First of all, there's no 5 there. But what I can do is I can go ahead and take a look and see what is the slope around the point. And if you notice, this piece right here between 4 and 6, between 4 and 6 actually gives me a good place to estimate slope because 5 is halfway between those two. So what I can do is I can go ahead and look at f of 6, which is going to be 212, minus f of 4, which is 186. And we're going to go ahead and we're going to divide that by our x value, x6 minus our x value 4. So if you kind of think about it, the limit as we are approaching that number is basically going to be this slope between that number. So to estimate it, basically what I'm doing is I'm taking w of 6 minus w of 4 over 6 minus 4. y2 minus y1 over x2 minus x1. And when we actually simplify that out, we get 13. So what we're saying is that w prime of 5 is going to be approximately equal to 13. And that's how we do that one. Okay. So that's from a table. So, I'd be really good. I could estimate it at 0.5. I could estimate it at 1.5. I could estimate it at 2.25. I could estimate it at 3.75. Kind of like the halfway points. I wouldn't want to pick bigger ranges. Like I said in the first video, the farther you are apart, the more likely there could be some kind of weird things going on in between. So we don't want to do it too far apart. We want to kind of pick the closest 2 points. Okay. So again, the rest of this is just the practice. So again, let me just walk through another example. I'm trying to find the equation of the tangent line at x equals 1. So what I'm going to first find out is what is f prime of 1, because that is going to tell me slope. F prime of 1 is going to tell me slope. So I'm going to use that limit thing that we talked about. X approaches 1, f of x minus f of 1 over x minus 1. And I'm going to figure out that f of 1, I'm going to need it anyway. F of 1 is going to give me 2 times 1 squared plus 1. It's going to give me 3. So basically, this point I'm at is 1, 3. And now I'm going to go ahead and rewrite this limit. The limit as x approaches 1 of f of x, which is 2x squared plus 1, minus f of 1, which is 3, over x minus 1. The limit as x approaches 1, if I simplify, it becomes 2x squared minus 2 over x minus 1. It's always going to give me 0 over 0. I'm just going to let you know. So we need to do some factoring. So this is the limit as x approaches 1 of 2 times x squared minus 1 over x minus 1. That's a difference of squares again. Limit as x approaches 1 of 2, x minus 1, x plus 1 over x minus 1. Cancels out. When I plug in that number 1, 1 plus 1 is 2, 2 times 2 is 4. That tells me that f prime of 1 is 4. The slope of the tangent line at 1 is 4. And if I want to write the equation, I do y minus y1, y minus 3 equals 4 times x minus 1. And that's my equation of my tangent line. So this is my tangent line. And just as a review, if it asks you for the normal line, remember normal is negative reciprocal. So it'd be y minus 3 equals negative 1/4 x minus 1. And that's what we did last time. What we're going to do today, what we're going to do in the next class is we're going to actually talk about some rules of derivatives that kind of help us shortcut some of this stuff. So hopefully that'll make things a little bit easier. Once we get through this definitions, we move on to the rules, and the rules are the way we're going to proceed. So please let me know if you have any questions.